Hi, welcome back to Mr. Slover's Math. Today we're going to talk about finding the surface area of a prism. So the first part is asking, what do we see? This one is a two-dimensional shape. This one is three-dimensional. It's got solid lines. It has both solid and dotted. It's got one rectangle, many rectangles. So that's what I was looking for on number one. And maybe you noticed other things that I didn't have listed, which is perfectly fine. Identifying your figures. Since we're moving into or moving away from two-dimensional to three-dimensional, we do need to know how to name these figures because that's going to help us in identifying which formula to use to find the surface area or eventually the volume. And typically we name them by their base. So we need to make sure we understand what some of these might be called, named based off their base. So if I have a base that's three sides, my base then is a triangle, or a quadrilateral is four sides, a pentagon is five, hexagon has six sides, heptagon has seven, octagon has eight, nonagon has nine, and decagon has 10. There are other ones, but for purposes of this class, these are the ones that we're going to focus on, and we really won't even talk about all of them. We're going to focus a lot on a base that has a triangle or a quadrilateral, or even a pentagon or hexagon. And this is asking you to talk to someone around you about whatever it's asking. This is a prism, so it's three-dimensional figure. Think of a cereal box as a visual. Okay? So imagine a cereal box. That is an example of a rectangular prism. You have a base, you have a face, which is the front side, and then you have an edge. So bases are parallel and congruent in a prism. Prisms also have lateral faces and that are not the bases. Lateral faces intersect at lateral edges, which are parallel. Altitudes of a prism are segments that are perpendicular to the base, and we're going to have straight lines with no curves. So some of these don't make a whole lot of sense because we haven't been talking about them, like lateral face or altitudes or perpendicular. It's been a while since we've seen some of those phrases, and that's okay. We don't have to remember all of this in order to help us find the surface area of a prism. So you name a three-dimensional figure by its base. You will look for the non-rectangle shape, and that will be your base. Okay? Since we're focusing on prisms, you're looking for a non-rectangle shape. If every shape that you see in the drawing or in the figure is a rectangle, it's a rectangular prism. So I'm going to start you out early by tracing out, highlighting, outlining your base. And this is going to continue from today through the rest of the unit. And that's going to help us figure out how to name the shape. And it's also going to help us when it comes time to finding the surface area or the volume. So the first example, I highlighted all of my bases. I'm looking for the non-four-sided figure, so the non-rectangle. So in letter A, that's this front part, which is a pentagon. It's got 1, 2, 3, 4, 5 sides. So 5 sides we saw up here was a pentagon. So that my base is a pentagon, and so that makes this a pentagonal prism. So remember, a prism, think a tissue box, think a book, think a cereal box. Okay, all of those are prisms. The next one, my base is a triangle. It's got 3 sides. A triangle has 3 sides, so my base is triangle, so it's a triangular prism. Everything in here is a rectangle. That's all I see are rectangles. So my base is a rectangle, which makes it a rectangular prism. And the last one, I chose my base on the bottom this time. Okay, but really they're all squares. Every shape I see in letter D, every face, every base is a square. So that makes it a cube if they're all the exact same. So this, once again, we're going to be using for the rest of the semester. So hopefully that will help us figure out the surface area or area. Surface area, just like with area, is always labeled in square units, which means it has a power of 2. So like centimeters squared, meters squared. And that's what example 2 is asking us to determine. Find or circle something that represents surface area. So A, B, G, and H do not represent surface area. They are just lengths. 7 miles, 2 inches, 32.02 yards, 7.98 units. The ones that I have circled, C, D, E, and F, are all representations of surface area because they have the squared, units squared, meters squared, millimeters squared, miles squared. So that's what we're looking for when we label. We're looking for those square units. To find the surface area of a prism, for purposes of this class, we are going to use the formula pH plus 2b. Now, right now, it doesn't make a whole lot of sense. But the uppercase P is the perimeter of the base. And if you forgot how to find the perimeter of something, it's where you add up all of the sides. The H in the formula represents the height of the prism. Not of the base, but the height of the prism. And then the uppercase B represents the area of the base. So notice that in 2 separate parts of the formula, we are focusing on the base. And that's why I am going to have you highlight, outline, trace the base, because it is important. We use it several times in order to find our surface area or volume. So here's just a picture. I have the base, which is over here. Remember, it's not usually on the bottom, or it doesn't have to be. Most of the time in prisms, your base is actually on the right or the left-hand side. And then down here, the H is how tall the prism is. If the base is on its side, think of it in terms of the length. So just a different way to think about it. Don't assume that the height has to be something that is vertical. Okay? Because if I have my shape that's on its side, my height is now not vertical. So here's my formula. In all 4 of these examples, I'm doing the exact same thing. I'm trying to stair-step you into getting the correct answer. So we're identifying the base, we're naming it, finding the perimeter of the base, the height of the figure, the area of the base, and all of that is stair-stepping us into just plugging it into the formula for the surface area. So the base on this side, or in this example, my base is right over here, outlined in red. It is a rectangle. So based on that, I use the base to name my figure. It's a rectangular prism. The perimeter of the base, that's why I highlighted it, or that's why I outlined it in red, so I can reference it. In a rectangle, your opposite sides are congruent. So the bottom is 8 and the top is 8. That's why we see 8 twice in here. And you may be wondering where the other number came from. Well, back when we discussed what some properties of a prism were, we stated that we had parallel and congruent bases. So if this is a rectangle over here with dimension 8, that means this side is the same thing with the dimension of 8 down here. Well, likewise, because this dimension is 10, this dimension is 10. So my rectangle has dimensions of 8 by 10. So that's where the 10 comes in when I find the perimeter. Okay? Opposite sides are congruent, so I have a 10 and then another 10. So my perimeter of that red rectangle is 36. The height of the figure, since this is my base, my height is right here. It's kind of like the length because my figure is on its side. So 24. Area of the base. So the area of the base, because it's a rectangle, is base times height. So 8 times 10. Now I'm going to plug all that information in. Now it's a big substitution problem. The uppercase P, perimeter of the base, 36. The height of the figure, 24. Plus 2 is always going to be in this formula. Right? It says plus 2 times B. So 2 is there. And then times the area of the base, which we said was 80. So I get 864 plus 160. When I add them together, I get 1,024 square inches. Letter B is very similar. So I want to look at letter C because now I'm switching. This time my base is a triangle. So based off of that, that means I'm going to name it as a triangular prism. The perimeter of my base, since my base is a triangle, I'll have three numbers that I'm adding up. 3, 4, and then 5. Just like in example A, my opposite sides, my opposite bases were parallel and congruent. Same thing here. This front triangle and the back triangle are congruent. So because that's a 5, that's a 5. The height of the figure, 6 meters. Area of the base. Here's the formula for the area of the base. You may be thinking, where did that come from? My base is a triangle. So the area of a triangle is a half base times height, or base times height divided by 2. They give you the same answer. Either way, the area of your base is 6. And then you're just plugging in your three pieces of information. The perimeter of your base is 12. The height of the prism is 6. Plus 2 is always there. Then you're multiplying by the area of the base, which was 6. So I end up with 84 square meters is my surface area. So here's the formula that we're using. Surface area equals the perimeter of the base times the height plus 2 times the area of the base. Before I sign off, let's reiterate what surface area is. Surface area is just that. It's the area of the surface of your figure. Okay, so every single shape, each of those areas added up, that is the surface area. Let's think of this as a real world application. You're deciding to give Mr. Slover a present, but you want to surprise him for what it is. So you need to wrap it. That wrapping paper is an example of surface area, how much wrapping paper you would need to wrap something. Okay, so there's your